Hello students, I am Manoj Kundare, the Assistant Professor of Electronic Science. Welcome back to our e-learning platform. In previous video, we have seen the structure of the Kmap for the 2 variable, 3 variable and 4 variables. The link of the previous video is available in the description box. Please check it. Now, in this video, we are going to see the simplification of Boolean equation using Kmap. The simplification of Boolean expression using Kmap based on the combining and grouping the terms in adjacent cells or boxes of the Kmap. Here, adjacent means the neighboring cells. Okay. The two cells of the Kmap are said to be adjacent as shown in the following figure. That means the two cells of the Kmap are adjacent if and if the Kmap is shown here. That means the cell 1 and 2 are adjacent with each other. Cell 1 and 5 is adjacent with each other, but the cell 1 and 6, that means 1 and 6 or 2 and 5 are not adjacent with each other. Okay, I hope you all understand the adjacent means the neighboring concept. Okay, let's see once again. The cell 1 is adjacent with 2, 2 is adjacent with 3, 3 is adjacent with 4. Similarly, 1 is adjacent with 5. Okay, this 2 is adjacent with 3, also 2 is adjacent with 6. Next is 3 is adjacent with 4. This 3 is adjacent with 4, 3 is adjacent with 7. Okay, the 4 is adjacent with 8 and 4 is adjacent with 3, vice versa. Okay, now the cells on the left or right side or at the top and the bottom of the cells are adjacent cells, but the cells connected diagonally are not the adjacent ones. The leftmost cells are adjacent to their corresponding rightmost cells as shown in following figure, and the top cells are adjacent to their corresponding bottom cells. That means in this diagram we can see here that this is the leftmost and this is the rightmost, and these two cells are adjacent with each other. Similarly, these two cells are adjacent with each other. Okay, I hope you all understand. Let's see once again. If this is the Kmap, okay, now we can say that there are some adjacent cells, that means neighboring cell. This cell is neighbor with this cell. Okay, we can also say that this cell is neighbor with this cell, or this cell is neighbor with this cell or adjacent with this cell. I hope you all understand now the concept of the neighboring or the adjacent cell. Okay, now let's see how does the simplification takes place. The first one is, once we plot the logic function or the truth table on a Kmap map or Kmap, we have to use grouping techniques for simplifying the logic function. The grouping means combining the terms in adjacent cells. The grouping of either adjacent ones for SOP or adjacent zeros for POS result in simplification of Boolean expression. That means if we have any logical function or any truth table, then we have to plot first it Kmap. Then we have to fill the values of zeros and ones. If we want to simplify the expression in SOP, then we have to group the adjacent one, and if we want to simplify for the POS, then we have to group the adjacent zeros. Okay, now let's see the way of grouping. While grouping, we should group most number of ones. The grouping follows the binary rule That is, we can group 1, 2, 4, 8, 16, 32 number of ones. While simplifying the Kmap, we should first find the octet. If the octet is not present in the Kmap, then we should find the quad. If quad and octet is not present in the Kmap, then we should find the pair. And if octet, quad and pair is not present in the Kmap, then we should keep it as a single. That means in a Kmap, we have to find first the octet. Octet means the group of 8 adjacent ones. Then if the octet is not present, then we have to find the quad. Here the quad means the group of the 4 adjacent ones. If the octet and quad is not present, then we have to find the pair. The pair means the 2 adjacent ones, and if octet, quad and pair is not available, then we have to keep it as a single. For example, let's see here. This is the Kmap. Okay, this is the 4 variable Kmap. In this Kmap, if we have any logical expression, then we have to enter the values according to the expression or the truth table. If we get the values such that, okay, if we get the Kmap of this, then our first step is find the octet. Okay, our first priority is find the octet. Octet means 8 adjacent ones. Here we get the 8 adjacent ones, hence we get the octet here. Okay, if the octet is not present, that means if, let's consider the next Kmap. If the octet is not present, that means in this Kmap the octet, that means 8 adjacent ones are not present, then try to find the quad. Quad means the 4 adjacent ones, and here is the 4 adjacent ones, we get quad here. If octet and quad both are not present, that means let's see once again the Kmap. This is the 4 variable Kmap. In this Kmap, if in this Kmap for the one there is no octet, that means no 8 adjacent ones, there is no quad, that means no adjacent 4 or no adjacent 4 ones, then we have to find the pairs. Pair means the 2 adjacent ones. Here these ones are adjacent pairs. These ones are adjacent to each other. Hence in this Kmap we get the 2 pairs 1 and 2. Okay, and if in the Kmap the octet or the quad or the pair is not available, then keep it as a single. For example, 0 0 1 0 1 0 0 0. Here this one is single here. Here is no one, no one. That means this one has no adjacent one. For that purpose, we have to make it single. Similarly, this one is a single. I hope you all understand the concept of octet, quad, pair and single. Now let's see the way of grouping. Octet means a group of 8 adjacent ones or zeros is called as octet. Quad means a group of 4 adjacent ones or zeros is called as quad. And pair means a group of 2 adjacent ones or zeros is called as pair. Now let's see grouping of 2 adjacent ones, that means pairs. The first Kmap is given here that this Kmap is for 3 variable. In this Kmap we can see that A, B, C are the 3 variables and this is the Kmap for the same. Here in this Kmap we can see here that this is the value 0, 1, 0, 0, 0, 1, 0, 0. here these two ones are adjacent with each other, hence a pair is made here. Okay, for this one we get the expression as, let's see once again, for this one we get the expression as a bar b bar c. That means a bar b bar c. For this one we get the expression a b bar c. A b bar c. This is our y1 and this is our y2. We get here y equal to y1 plus y2. That means a bar b bar c plus a b bar c. Okay, in both the terms we get b bar c common here, hence in bracket a bar plus a, but we know that a bar plus a equal to 1, hence we get here y equal to b bar c. Here a is eliminated. I hope you all understand how to simplify the Kmap. Let's see once again the another example. Here the another Kmap is shown here, in which all the values are zeros except this and this box, but this one is adjacent with this one. Okay, hence we can make a pair here. This is the pair. We can find the equation for this one as a b bar c bar, and for this one a b c bar. Okay, a b c bar. Then we get y is equal to a b c bar plus a b bar c bar. We get here common a c bar, in bracket the remaining is b plus b bar, but b plus b bar is equal to 1, hence we get y is equal to a into c bar, and this is the eliminated equation or the simplification of the Kmap. Okay, let's see some examples here. Here is the two variable Kmap is shown, in which there are 3 ones and 1 0, hence we make here the two pairs. This one is pair and again this one is pair. The pairs or the grouping may be overlap to each other. Okay, the equation of this pair is that here we get for this one a bar and this one b bar. Okay, a bar and b bar, plus for this one we get here a bar and b. After simplification this, we get a bar common here, in bracket we get b bar plus b, but b bar plus b is equal to 1, hence we get a bar. That means here b is eliminated. Here we get the second pair here. For this pair the equation of this one is a bar b bar, a bar b bar, and equation of this one is a b bar. Okay, equation of this one is a b bar, hence we get here b bar. The a is eliminated. Let's see once again. This is the Kmap for the two variable is shown here, in which at the side a b, a has the value 0 or 1, b has the value 0 or 1. 0 a equal to 0 means a bar, a equal to 1 means a, b equal to 0 means b bar, b equal to 1 means b. Here we have the Kmap like this. Okay, here there are 3 ones, hence we can make here a pair. For this one we get the equation a bar b bar, a bar b bar, plus for this one we get the equation a bar b, a bar b. In both the terms we can see here that a bar is common, hence we get b bar plus b, but b bar plus b is equal to 1, hence we get here a bar. Sorry, let's see once again. Here in this pair we get here the equation a bar b bar, that means a bar b bar, plus for this one we get here a b bar, a b bar. Here b bar is common, and in bracket a bar plus a, but a bar plus a is equal to 1, hence we get here b bar. Then we get the final equation as a bar plus b bar, that means a bar plus b bar. I hope now you all understand this Kmap. Let's see the next example here. The three variable Kmap ABC, and we get the values of ones here 1 1 1 1. Here if we look at this Kmap, then we can find that there is no octet or no chord. Hence we have to make three pairs. This is pair first, this is pair second, and this is pair third. Okay, but here only two pairs are made because this one is occupied in this pair and this one is occupied in this pair. There is no need to make this pair. Okay, our aim is that to cover all the ones and to make the less number of quads, pairs or octet, etc. Okay, that means we get the only two pairs here, this pair first and this pair second. Okay, the equation of pair first, that means this equation of this equation is here for this one we get a bar bc, a bar bc. For this one we get a bar bc bar, a bar bc bar. Okay, here the a bar b is common in bracket. Here c plus c bar, the value of c plus c bar is equal to 1, hence we get a bar b. Now for this equation or for this pair, the equation of this one is here is a and here is b bar c, means a b bar c, plus for this one the equation is a bc, abc. In both the terms AC is common in bracket, the remaining is b bar plus b, but b bar plus b is equal to 1, hence we get here AC. Okay, then add these two product terms, that means a bar b plus AC is our final simplified equation of this Kmap. I hope you all understand this. Now while grouping of two adjacent ones or pairs, if we group two adjacent ones on Kmap to form a pair, then the resultant term will have one less literal variable than the original term. That means by pairing two adjacent ones, we can eliminate one variable. Okay. Now let's see the grouping of four adjacent ones or chords. Here is the Kmap for three variable is shown here. In this Kmap, we can see here that there are four adjacent ones, hence we can make a quad of it. Okay, then let's simplify this equation. The equation for this one is, or the min term for this one is, this a plus b bar c bar. Okay, that means a plus b bar plus c bar. For this one is a b bar c. Okay, for this one a b c. For this one a b c bar. Okay, after getting all the min terms, then we have to find the common terms. In these two and these two we get the common. Here in these two we get the common ab bar, and in bracket the remaining is c bar plus c. Similarly in these two terms we get common ab and in bracket c plus c bar, but c plus c bar is equal to 1, hence we get here ab bar plus ab. Okay, now again here a is common, hence we get a into bracket b bar plus b, but b bar plus b is equal to 1, hence we get here the term y is equal to a, and this is the simplification of this Kmap, y is equal to a. I hope you all understand. Let's see this Kmap now. In this Kmap there are four adjacent ones, hence we make the quad of it. Okay, for simplification, find the min terms associated this one. We get here a bar b bar c bar. For this one we get here a bar b bar c. For this one we get here a bar bc. For this one we get the min term a bar b c bar. Okay, then find the common terms. Here in first two terms the common is a bar b bar and in bracket c bar plus c. In last two terms the common is a bar b and the remaining is c plus c bar plus, but c plus c bar is equal to 1, hence we get here a bar b bar plus a bar b. Again here the a bar is common, hence we get a bar into b bar plus b, but b bar plus b is equal to 1, hence we get here only the a bar, and this is the eliminated equation of this Kmap. Let's see the another examples. Here in this Kmap there are 4 adjacent ones, hence we make the chord of it. Okay, then we have to write, or we have to simplify this Kmap by writing the associated minterms with respect to these ones only. For this one we get here a bar b bar c. Okay, for this one we get here a bar bc. For this one we get here a b bar c, and for this one we get a bc. Okay, then after writing all the minterms we have to find the common. In first two terms the common is a bar c, and we get a bar c into bracket b bar plus b. In last two terms the common is ac, and we get ac into b bar plus b, but b bar plus b is equal to 1, hence we get here a bar c plus ac. Again in these two terms we get c as a common, hence we get c into a bar plus a, but a bar plus a is equal to 1, hence we get the equation c here. Okay, let's consider this Kmap. In this Kmap there are 4 ones, that means this one, this one, this one, this one. We can make 2 pairs, but our rule says that first one is try to find the octet. If octet is not present, then try to find quad. If quad is not present, then try to find a pair. But here these two ones are adjacent with these two ones, hence we can make a quad of these 4 ones. Okay, then after simplifying this we get the equation c bar. Okay, now let's see one more Kmap here. Overlapping of quads and pairs. As we seen previously, the quads or octet or pairs can be overlapped with each other. In this Kmap, we get one quad and one pair. The equation of this quad is b and equation of this pair is ac. Hence we get the total equation y is equal to b plus ac. Okay, I hope you all understand the concept. Now let's see the grouping of 8 adjacent ones or octet. It is possible to form a group of 8 adjacent ones such that a group is called as octet. When octet is formed, 3 variables will change and get eliminated. That means this is the Kmap of 3 variables is shown here, and in this Kmap all the boxes have the values 1, hence we can make it the octet. Okay, then we can simplify it by our procedure. That means by writing the minterms associated, this one is a bar b bar c bar. For this one a bar b bar c. For this one a bar bc. For this one a bar bc bar, and as so on. Then from each two terms find the common ones and eliminate these terms. Okay, then we get here a bar b bar plus a bar b plus ab bar plus ab. Then again try to find the common terms here and here. Here in this one we get the common a bar, and in this we get the common a. Okay, hence again we get here a bar plus a, and we know that a bar plus a is equal to 1. Hence after simplifying this Kmap we get y is equal to 1. Okay, I hope you all understand how to simplify the Kmap for or the Kmap octet, quad, pair and single. Thank you.